the Interplanetary Podcast is alive!
The Interplanetary Podcast, the exploration of space for the benefit of all humankind. Your host, in Guildford, England, Matthew Russell.
I'm joined on the podcast again by Chris Lintott, who is the Professor of Astrophysics at the University of Oxford. And actually, before we start, congratulations on becoming the Gresham Professor of Astronomy as well.
Thank you. Yeah, Gresham's a spectacular place, giving free lectures for more than 300 years now to anyone who cares to drop by online or in person. It's been great fun to be part of it so far. And to write some new talks, actually, and talk about some new things, several of which overlap with the book that I know we'll be discussing.
I've noticed that Sir Christopher Wren is amongst the people that have, and John Barrow as well.
Yeah,
amongst the people.
The recent predecessors are the scary ones: Frank Close, Martin Rees, John Barrow. I actually went to John Barrow's Gresham lectures when I was a student, and it's been a platform for all sorts of people. But it used to be a venue for jobbing astronomers. So Christopher Wren, when he finished his degree here in Oxford, got this job in London, and it had accommodation with it. So he and the other professors used to live in Gresham College, and it was supposed to be a university. It was the money left by Thomas Gresham's will said set up an institution for the people, and I think he meant a university, but they decided that was difficult and just kept the lectures bit. Wren was there before he came back here and abandoned astronomy, really. We always claim him, but he came back to Oxford as a geometer, professor of geometry, and then he got distracted by, all that architecture stuff, building St. Paul's.
He's pretty famous for architecture.
Yeah, exactly. But we'll claim it. Who says astronomy is useful? We produced one of the country's great architects, and who knows, one of my students here may go on to build cathedrals in their own time. We can't tell.
Who knows? Yeah, and talking of students, was Becky Smethurst one of your students?
She was my first PhD student, which I always tell people was like having a PhD student on easy mode, because Becky's always had her own ideas and was pretty self-directed. But of course, these days is YouTube's Dr. Becky. So we've long since passed the point where we try and impress prospective students by telling them I'm on the sky at night, and we just point them at Becky these days.
Yeah, well, yeah, I had her on the podcast, and she did wonders for my numbers, I have to say.
The thing that Becky has that I think is unusual in science communication is that she obviously speaks with a very deep expertise for the subject, but she's not afraid to go into detail, even though she's on YouTube, and you can pick up any newspaper article that'll tell you that the kids are people who get their information online are superficial or not interested in the detail, but it's also a place where you can sink into detail. And if lots of my colleagues, if they want to know exactly what's going on when they see the headline that says black holes take over universe, or astronomers find bigs, whatever, Becky's videos are a good place to turn, because she'll give you the real stuff. And it's something we've always tried to do on Sky at Night as well, and it's great to see Becky picking that up and running with it.
Yeah, absolutely. I have to say, if I read something that seems like it's improbable, like they found a black hole that's there before the start of the universe, and it's like, I'm going to watch the next Dr. Becky video, and I bet she'll talk about it, and she does, and she explains it. There's some great science communicators out there at the the and she's definitely
that's true. But it's funny how the headlines come around. There's we've had a star older than the universe several times in the last few years. It's not. There's the could this be aliens that comes around
every
lot.
day. It's
usually not. Threatening black holes. Black holes are some of the most fascinating objects in the universe, but it's always like threatening black hole. May kill Earth. And you're like, no, it's fine. They're friendly beasts. We're all good. These things come round. Alien spacecraft in solar system, it's not. So these stories do come round, but there's plenty of science to be talked about around each of them as well, which is something I always like trying to do.
Well, so your new book, The Our Accidental Universe, am I right in saying it's really about how a lot of the big discoveries in astronomy are about serendipity? Is that right?
That's right. Yeah, there's a couple of sort of things that induced me to write it. One is this sense, I think, that we know what we're doing as astronomers, which is a complete myth. But people, I think, do have this impression, and it's not helped by often the way that we're presented, as clever people doing clever things in ways that you couldn't possibly understand. the idea that we all sit around waiting for somebody to have an idea and they go, my God, that's it. I understand dark matter now. To the telescopes. Whereas actually the joy of astronomy is about the things we don't understand, the arguments in the corridor when there's a confusing result, the speculative idea, sometimes the object that comes out of nowhere passing through the solar system or, landing on a perfectly harmless bit of Gloucestershire or whatever, and that can change everything. So it's really this getting away from this sense of astronomy as a sort of cold and disciplined science and trying to bring people into the fun of doing it for a living and the fun of being on the cutting edge of this. I was trying to shape the book for a long while. I had a chat with Meg Urey, who's one of the smartest people I know. She's the person who worked out how black holes and galaxies relate to each other, professor at Yale. And we were talking about this and admittedly over a gin and tonic, but she reckons that there isn't a single big discovery in the 20th century that astronomers made deliberately, if you take the really serious ones. And I think, that's probably true. It's slightly unfair to things like cosmologists who were on track of the cosmic microwave background, this ancient light. But, the radio engineers found it first. And, the people who pioneered radio astronomy knew what they were doing, but the astronomers weren't listening to them. It was considered this bizarre thing that you did as a hobby. We found some near-Earth asteroids, but most of them by accident. And so I think wherever you look, there is this accidental universe surrounding us. And I think once you accept that, it changes your view of the universe, I think. It becomes a much more fun place to be. And I hope that people will, by the end of the book, really get the sense that being in an uncertain universe where things happen is exciting and it's to be embraced.
It's slightly different, isn't it, with something like the 1998 dark energy thing where it's like you're trying to look for something and you get a result that you really weren't, no one's expecting.
Yeah, this is a good example because there were two teams at the time who were setting out to measure the slowing down of the universe. So we know that it's expanding. We've known that since the 30s, but we thought it should be slowing down because gravity is the only force that acts on a universal scale. And gravity, as we know, pulls things together. So therefore, the universe should be slowing down. The more stuff there is, the slower it should be going. And so it's a way of weighing the universe. So there were two teams who set out to measure this. One of them had as their website, the headline was setting out to measure the deceleration of the universe. And both of them found that the universe was speeding up. So one of the interesting things about that is that they believed their results. So the book celebrates. I would like to celebrate people who are happy to be surprised, and so it would have been very easy, I think, for both teams to decide that their results were wrong, that there was some error, that they'd done these quite difficult measurements of distant supernovae wrong, and to hold on. And I think partly the fact there were two teams helped because it meant that they always worried that the other team were behind them. And it must have been a great moment when they realized they both had the same result. The other thing is that we probably shouldn't have been surprised by that. If you look at the theory papers at the time, it's clear that the universe doesn't quite add up. If you look at where the energy in the universe is, it doesn't quite add up to the total that we think it has. And so there has to be another force, another thing acting, and that is this dark energy, this accelerating force. So, I think there are a few people who sort of half predicted what we should find, but no one came out and had the courage of their conviction and said, if you make this measurement, you will find the universe is speeding up. And so, one for the observers. Yeah,
it would have been good if Einstein had left it in, the constant in, and sort of...
well, he gets all this credit, right? So Einstein's theories are used to describe this. Well, the first mistake that Einstein made was that he thought his theory needed to describe a static universe, because the astronomers in the 20s told him that the universe was static. We don't see, if you look at the night sky, you don't see any evidence for things moving around. And he invented it, but he knew that gravity should pull things together. So he invents this anti-gravity force, sometimes called the cosmological constant. We now call it dark energy. And then it sort of goes away when they realize the universe is expanding. And so it's called Einstein's blunder, though it's not clear that he ever referred to it as that. But I think, and then nowadays he gets a lot of credit because this thing comes back. It's like, oh, well, Einstein was right. Well, he didn't do this for the right reason. He's got enough. He basically
has got enough
gravity, discovered atoms, and laid the foundation of quantum mechanics. Let's not give him more credit than he needs. So, I think, he he doesn't get the points from me because he didn't say, oh, well, there will be an accelerating force needed to account for 70% of the universe's energy density. And by the late 90s, we'll discover that. So no points for Einstein there. But maybe a sense that it had been in the idea of this force had been around for a while, and people could have taken it from the cosmic toolbox, but they didn't expect to be surprised, right? They knew that the universe was slowing down, so that's what we'll account for.
Yeah, have you got any personal kind of experience where an unexpected event or accident has led to a significant finding in your own research?
The first of those is the realization that I built a tool for being surprised. So my own research, as you know, has been over the last 15 years, mostly through the Zooniverse. So this platform that invites everybody to come and look at data. And originally we thought of Zooniverse projects like Galaxy Zoo, which asked people to look at the shapes of galaxies, as a tool for classifying things we knew about. Here's a galaxy, tell us if it's a spiral or not. Great, it's a spiral, I'll put that in the spiral box, I'm done. That was what we were thinking. But of course, if you have people look at your data, then there's this very human tendency to be distracted. And yes, you get, this is a spiral, this is an elliptic galaxy, but you also get, hey, this one looks like a penguin. This one appears to be a spectacular merger. This one looks like a small green pea, and the Galaxy Zoo volunteers discovered these green pea galaxies that turned out to be the most efficient factories of stars in the local universe. They're fascinating objects. And astronomers being astronomers, we've now found string bean galaxies to go with them. So we're halfway to a salad. I think the one that really exemplifies that was our Planet Hunters project, where we were looking for planets around other stars, and you detect these planets by transit. So you wait for them to go in front of the star and you see a dip in brightness. But there was one particular star that showed a really unusual pattern of dipping. It dipped a couple of times, waited a year, then faded by 20% for a few hours, and then came back to normal. And then after another year, went crazy for a period of about a month and a half or so. This is what the volunteers called the WTF star. You can work out the acronym, I'm sure. It stands for Where's the Flux, because something is hiding this missing light. Yeah, you have to spell out acronyms in journals. Luckily that's what it's for.
Do you know what? I've been pointing out to my students it's an initialization rather than an acronym. An acronym has to spell a word. Did you?
Oh, I see. Yeah. Okay. Well, in astronomy, we as you know, we play fast and loose with all of these rules.
Like metals and things like that. It's like
I was just using a code today called bagpipes, which I won't even tell you what it stands for, but it has very few of those letters in it. Anyway, so this star, we were trying to work out what it was. We did all the checks. This is led by Tabby Beauregin, so it's sometimes known as Tabby star, or more properly as Beauregin star. So we even got to the point where we were looking at which pixel on the camera took each point of data in case there was one pixel that was, not responding properly, but it wasn't that. Yeah, we came up with all sorts of ideas, none of which were very good. And we eventually published a paper that basically said, WTF, we don't know what this is. And then Jason Wright and colleagues in the US published a paper, said, oh, we know what it is. It's an alien megastructure. And so the first I knew about this was the phone in my office ringing, and I think it was the Daily Mail on the line saying, I hear you've got evidence of aliens. And they're sitting here going, it's Monday morning. I think, checking my email just in case I'd missed something. So that was a fun adventure. So, what that turned out to be probably was, well, people don't really know, but we did show that it's not a solid object. So it's not an alien megastructure. It's not some vast space station or collection of solar panels. It's probably a cloud of dust or something like that. But finding that has led people to find a whole host of stars that do this, that show these dramatic dips. It's made us think differently about what we're going to find with new surveys, and it has opened up this new study of dramatically misbehaving stars. But it started with somebody on the Planet Hunters site going, that's a bit odd. And lots of these stories have somebody in there just going, that's a bit odd. And I think that's part of the fun of it.
Yeah, no, absolutely. So do you think that in the next sort of year or so that we're going to have some big shockers in astronomy? Because I've noticed that ever since James Webb has launched, we've got this kind of accelerating story of just odd things out there where like we started with a black hole older than the universe and all those kind of crazy
Yeah, we
Stories
should know not to be. But certainly we see black holes older than we thought they were going to be.
And bigger,
you know,
bigger as well? Bigger than they are supposed to be?
Bigger earlier than they should be.
Yeah.
So the early universe started with a bang. I mean, that's true sort of literally, but these early galaxies seem to have formed stars very rapidly, and they seem to have formed black holes very rapidly. And I think we're at the point with JWST where we're sure that the measurements are right. These galaxies really are there, but either we don't understand something about the galaxy, so maybe they're forming different kinds of star or something like that, or we don't understand something about the universe, which is the more exciting one, or we don't understand something about cosmology and we have to change our theories. So I think in the next year there'll be consolidation there. We need to look at more of these things. It turns out, if you look closely, they've all got individual stories to tell. The thing, probably a year is a little soon, but I'm very focused, and the book ends with the upcoming Vera Rubin Observatory, which is just the most magnificent device. It's an 8-meter telescope, so as big as the biggest telescopes in the world today, except that it's going to scan the whole sky. It's going to do a survey. So every 3 nights, you get 30 terabytes of images, every night you get 30 terabytes of images. And you also get something like 10 million alerts telling you that something in the sky has changed. So there's something flickering or moving or getting brighter or fainter. And my guess is that every time we've looked at the sky in a new way, and this is a brand new way of doing this sort of thing, we've discovered new kinds of object. Jocelyn Bell's pulsars, asteroids when in the inner solar system, quasars when they got the big spectra, and black hole activity and so on from radio telescopes in general. So I think we'll find new things in there. And first light, we're hoping what we call first photon, so literally the first light to go through the telescope and bounce off all the right bits, will be this summer, and then the survey will start in 2025. So give us a few months after that, and I think we'll have a torrent of discoveries. Ranging from the distant universe all the way down to the solar system, I think.
Yeah, because there's so many observatories that seem to be coming online, and presumably they all interact with each other to kind of create a much, like, it seems that James Webb's big power is to be combined with Hubble and can be combined with Gaia and can be combined with all these
you always want to mix these things together, I think, because they all do different jobs, but I think Rubin and its LSST survey will be the base for lots of what you do with these other telescopes. So when we find an unusual object, telescopes in Chile and in space will jump into action to follow it up. So I think you always need these surveys. But traditionally, surveys have been done with small telescopes, and then you follow them up with bigger telescopes. This is an 8-meter. So we're already going to get amazing images. To the extent that we don't really know how to cope with some of what we're getting. We've spent 10 years assuming that we'll write the software, we'll fix the problem before this thing comes online, and it's all getting a bit real now. Yeah. But it should be really exciting. I mean, if you look at this, I wish I could show you the simulated images, but if you look at a normal galaxy in what we think the survey will produce, because you can get very deep images if you go back to the same patches of sky night after night, then almost every galaxy will be embedded in this halo of tidal tails and disrupted gas and so on. So the disk, it's like seeing the top of the iceberg, and we're about to see the rest of the iceberg for the first time. But we don't really have language to describe the structures that will be there or to categorize them. So our first task is working out what's a useful thing to say about this new view of the universe. It feels honestly rather like the birth of radio astronomy, where they had to invent a whole new way of looking at the cosmos.
Yeah, so the survey telescopes, presumably they create so much data that it's going to, how long, I mean, is it decades to actually kind of work your way through the data?
Oh, I'm sure. I mean, we're still using survey data from 20, 30, 40, 50 years ago. So Rubin's a 10-year survey in the first instance, but we think that will keep us going for a long while. And we'll work out what to do after that with this 8-meter when we get there. But no, it's special because it's the whole sky. So it's got a very wide field camera. And so it will be able to do the whole sky. So we're used to either, and again, this is one of the stories of the book, either you do a survey of the whole sky, or you do something like the Hubble Deep Field and you drill deep into one patch of sky. JWST is doing a lot of this as well. Rubin's almost the best of both worlds. So we're going to get a deep image across the whole sky. And all sorts of unusual things are going to jump out. Some we know about, like the sort of archaeology of the galaxies that will show us how they've merged and interacted. Others are pretty speculative. So, one use case that my friend Phil Marshall has been pushing for years is that some theories of particle physics suggest there could be things called cosmic strings. So these are very massive particles that are sort of left over from some exotic phase early in the universe's history. If you see one of those, it will bend light so that you get a disconnect. So it's almost like a rip in space-time. Maybe we'll see that in Rubin, but we're only going to do that if we're prepared to look for very unusual things. So we need to be open to all possibilities with this very large data set, which is a hard thing to do, right? If I want to go looking for supernovae, I write some software that finds supernovae. If I want to go looking for interesting stuff, I have to think a lot harder about how to handle 30 terabytes of data a night so that we can be surprised.
Doesn't your book suggest, really, does it suggest that perhaps when you're looking for things like cosmic strings and you're doing these really unusual ways of looking at the universe, you're actually probably more likely to see something that you hadn't bargained for at all?
That's right. Yeah, I think that's right. But you have to design your search so that you can be open to finding unusual things. I have, this building, I'm sitting in my office, this building is half astronomers and half particle physicists, and I love my particle physics colleagues. They're very sensible people. They're very interesting. But I'm slightly horrified by the way that their collider in Geneva works, the LHC, not because it's going to end the world or produce black holes or anything like that, I hasten to add. They're not a threat. But there's so much data produced by that machine that it's filtered as it's produced. So they have to write code that tells the machine what they're looking for, and it only saves events that correspond to things that they're looking for. So much more than 99% of data produced by the LHC never even gets written to disk. And so if by colliding particles together, you're doing something completely unexpected, we're producing, let's call it the Lintott particle, just for argument, which, turns in spirals and sticks two fingers up to you or whatever. It won't show up in the data. They can't be surprised completely by their data.
Has anyone ever thought about writing like a random code so they just run it for a bit and
they do save a little bit. So we actually run a project on the Zooniverse called Higgs Hunters, where we were looking through that random trench, and we said to people, look, the odds of this project finding anything are nearly zero. If you find anything, you'll be the most famous physicist in the world and win a Nobel Prize. But in astronomy, I think we can do better than that. With the combination of machines and lots of hard drives and volunteers online, I think we can prepare to be surprised, and I think we need to do that. So the book ends with a sort of, hopefully it's interesting to everyone, but it's a call to arms for my colleagues to remember that we're astronomers, that we make progress by looking at the sky and by being surprised by it.
I mean, it is the golden age, isn't it? It is the golden age of what you're doing, the astrophysics. It changes. It seems to be changing so much, like even year by year, that the story. In terms of your own personal experience, you've been in the game a long time now. Presumably, it's a really exciting field to be in.
It is, and that's that's the most polite way I've ever been called old. So that was nice.
Not as old as me, so you're okay.
Yeah, I think that's right. I mean, I grew up as an amateur astronomer, and I think, like many people my age, I felt a sense that I'd missed out because I didn't see Apollo. I didn't have that memory of getting up and watching Neil Armstrong's one small step onto the moon. But I think I've come to realize that was the golden age of space flight, right? Of people flying around. We do, exactly as you say, live in the golden age of astrophysics with the telescopes that we have, with the discoveries that we've made. We're at the point where discovering a planet around another star is commonplace. Like, to the extent that it's hard to write a paper. If you just find one planet, who cares? Just stick it in the catalogue and we'll move on. If it's an unusual planet, then we'll listen. But that's happened in less than 30 years from the discovery of the first planet. We can detect colliding black holes routinely with gravitational wave experiments. We can see deep in the infrared with JWST. Some of the images from JWST are just astounding. And Rubin will be very exciting too. So I think the technology is good, and I think we're getting better at sharing it. So the way that I also think, I, as a kid growing up, being interested in astronomy, I had an extremely large pile of past issues of Sky and Telescope magazine to read through and a few books. But if you want to be a fan of astronomy now, you can be the first. If you're online at the right time, you can see the images coming back from the Mars rovers before the team that built them have seen them. Just by hitting refresh at the right time. You can, mostly they're calibration images, but occasionally you get a beautiful view. You can follow along with Ruben. Those alerts are going to be public to everyone. So if you want to, you could subscribe to some tiny patch of sky and keep an eye on it for us. You can see web images are beginning to be public. So they're made public as they come off the telescope and a little bit later. So I think there's great opportunity for people to be part of this adventure. Even if they've only got a few minutes a day, you can contribute via Zooniverse, but you can also just be a fan of the cosmos in the way that lots of us are fans of sports teams. And I think that's new, and that's part of why it's so exciting right now.
Yeah, it's definitely. I mean, just for that proliferation of YouTube channels that just talk about space, and even this podcast as well, where there's a genuine public interest because it is because it's exciting, isn't it?
Authors who write spectacular books that are about how
exactly.
you can be surprised. That's an important aspect of this as well, of course.
Yeah, no, absolutely. Well, you know, there's lots of books
and TV programs and TV lectures and
yeah, absolutely.
It's gone very Monty Python, this, hasn't it? It's like, what's astronomy ever done for us?
But yeah, so you're still doing Sky at Night?
Yes, I just had our first call about this upcoming year, so we're back in April.
Yep.
And we'll be doing all sorts of things.
Have you noticed a change there? Have you noticed a change with the shift of what you used to do on Sky at Night and where it goes now?
I think the technology is better, so we can be more playful and creative. When I started, I've been doing Sky at Night an awful long time now. I've been part of the permanent team for more than 20 years at this point. Wow. And my first appearance was 24 years ago this year. When I started, it was in a studio with a script and 3 cameras, and you could maybe drop 6 images in if you could afford it. But, what we can do now with people shooting on their own phones, or, I have a GoPro that I'm using, and we do have a camera crew, but we can do Skype interviews and Zoom interviews. And so I think we're able to tell richer stories, but the stories are the same. And it comes back to what we had at the top, I think, which runs through everything I try and do if I'm talking about astronomy, which is that Patrick Moore, when he was on Sky at Night, knew that he wanted always to talk about the latest results, talk about what's new. But he also knew that anyone running across that content that program might be watching for the first time. And so in the same show, you'd get Mars is the 4th planet from the sun. It's red, mostly a desert world with ice caps. And then you'd get, and the Phoenix landers discovered perchlorate, which makes the soil alkaline, which explains, but you get both halves of that. And I think there's great value in anyone who can communicate. And sound like I'm bigging myself up, but I think the important attempt is to communicate both of those things, to be as clear as possible and to be as straightforward as possible, because we've got great stories to tell, but also to give you the stuff that's just happened. My book contains things that even in the last month or two, I've had to squeeze in an extra paragraph, because the stories are particularly things like the story of phosphine on Venus, which might or might not be due to tiny penguins or maybe even bacteria flying around in the upper atmosphere. And studies of Jupiter's moons are ongoing. So yeah, we've tried to squeeze in the up-to-date stuff, because that's the excitement that is that this is changing.
Yeah, it's super change. Is there a kind of cut-off where your publisher says, "Oh, for goodness sake, stop phoning us up to change things"?
Yeah, I have told them we need to do version 2, but apparently some people have to buy version 1 first. Well, they'll let me do that. So the American edition is out in June, so they might get an extra paragraph.
Oh, wow!
And I've also done the audiobook, which was great fun. So people that's sort of the end point is me reading the audiobook, which was just before Christmas. But it really was down to the wire when we were squeezing things in.
That's definitely what the way that I consume my my books at the moment, because I've got long drives and it's like, yes, brilliant.
Great. Well,
So-
that'll be available pretty much as soon as the main book
when,
is.
when does
that'll
it
be
come
great.
out? March.
So in the UK and most of the world, it's March the 21st this year. If you're listening in the States, it's early June, and over there it's called Accidental Astronomy. Everywhere else, it's Our Accidental Universe.
Interesting.
Well, they did it for the Harry Potter books. You have different titles in the US.
Yeah, and films that all have different titles.
Yeah,
across,
we changed. They changed very little else. So I think my cricket reference survived unscathed. We had a very long debate over whether Murphy's Law and Sod's Law are the same, or whether they're different. So this is the detail that's gone into this publishing process.
Did you talk about real tennis in your?
Let's see then. I don't think there's much real tennis in there. I did insist. So on Titan, Saturn's moon, which is this marvelous. You're going to hear a lot more about Titan in the next few years because we've got the marvelous Dragonfly mission to go and fly a copter around. But in the methane nitrogen atmosphere of Titan, raindrops, which will be mostly methane, are the size of lawn tennis balls. And I've insisted that we distinguish a lawn tennis ball from a real tennis ball.
Yeah.
Because those anyone listening who knows me knows that real tennis is my other obsession, the old version of the game. And the balls are subtly different. So I've gone for precision there, much to the frustration of all of my editors.
Yeah, real tennis. I do love the fact that it claims the real bit as part of its title. It'd be a bit like calling it real football.
I mean, we just call it tennis, but to distinguish, for other people, it was tennis. The game is essentially as it was when Henry VIII played it. So almost nothing has changed. So we're the original version. The thing that other people know as tennis was invented to have a simple form of the sport that could be played at garden parties. Basically, it's supposed to be a muck around with your mates. So. Yeah, if people want to know more about real tennis, we should do a special episode, I think, just on that. Otherwise, I try and limit myself.
Have you tried to work out as many space analogies that can bring in real tennis?
I have. I've been trying to get real tennis onto the Sky at Night for many years. I thought I'd succeeded. Last April, we did a program about Jupiter's icy moons because we got very excited about the JUICE mission, which is headed the European JUICE mission, which is heading off there now. We've got Europa Clipper launches later this year as well. And the moons are made of water ice, but they have a liquid center. And that's because they're squeezed by Jupiter's gravity. And so it's the same physics as if you hit a ball against a wall, it will heat up. And so I thought, brilliant, a sport involving hitting a ball against a wall, this will be great. Unfortunately, the effect's more obvious with a squash ball. So we end up on a squash court. And I was going to interview Michelle Doherty, who's another hero of mine from Imperial College, who features in the book. It was her team who discovered the water fountains of Enceladus. But Michelle and I were going to meet on the squash court and discuss the moons of Jupiter, and we thought I hit a few balls. So I was there in squash kit, tennis kit actually. And Michelle walks in dressed for a day in the office. And I said, I thought we were going to play some squash. She said, no, I have too much dignity for that. And so the interview went out with me inexplicably dressed for squash. And it's only about halfway through that you realise. Actually, the other story for that is that the producers were very concerned about me. I kept getting questions as to whether I'd be all right on the squash court. I couldn't really work out what was going on, but I found the risk assessment, which said that the presenter plays racket sports weekly, and they'd misspelt weekly. So anyway, it's nice to know the BBC were looking after me, but I've never. It's a good analogy, I think. I thought that was very nice. The squeezing, like the squashing of the squash ball, creates these wonderful habitats that maybe the nearest life to us is sitting within one of these icy moons.
Yeah. So that there's a question what's going to be the most exciting branch of space in the next couple of years? Is it going to be your solar system stuff, or is it still going to be your sort of bigger universe stuff?
It's interesting. It's very. I think we're due a cosmological revival. So the solar system is fascinating, of course, but it takes time to get probes to places. And so I think in the next few years, we're going to have to be a bit patient. Dragonfly to Titan is going to be amazing.
Yeah, it's insane.
That'll be really exciting. But even that's a few years away. JUICE is on its way, but we've got another 6 years or so to maybe five and a bit years to wait.
It's an arduous journey, the JUICE one. It's got to do like 2 flybys of Earth as well.
Yes, I don't know if you've seen ESA has a juice bar on their website and on Twitter, which is now 5% full. So
Oh my
it's
God.
very much, hopefully it'll be like Apple Minutes and it'll speed up at the end. So that will be fun. And exoplanets are endlessly fascinating, but I think we're in a phase with JWST where we're discovering how little we know, actually, and that there's a lot of complex. I just said to my colleague Jane Birkby yesterday that the more I hear about what they're doing with trying to learn about exoplanet atmospheres, the harder a job I realise they've got. You know, we're still arguing about the atmosphere of Venus and the details of Jupiter's atmosphere. Trying to do that from a planet that's hundreds of light years away is very hard. So I think these galaxy results from JWST, I think that will resolve itself one way or the other. And if you think about it, we've been through a quiet phase with cosmology. One of the great things I've done in the last couple of years has been to revise the book Bang that I wrote years ago with Patrick Moore and Brian May, more than 20 years ago, actually. And it's a history of the universe. It tells the story of the universe from Bang to the far future in that order. It's quite fun. It's an interesting gimmick. And we sat down, Brian and I sat down to revise it in 2021, I think. And we realized that for the cosmology, the first few chapters and the last few chapters, the cosmology, basically, it was a case of changing some numbers. You know, the universe was 13.8 billion years old, not 13.7. As we migrate background was 400,000 years old, not 300,000, that sort of thing. We had a few nice pictures to put in, but basically the story was the same. It'd been a very quiet 20 years of consolidation, I think. We ripped out the middle 3 chapters and brought in Hannah Wakeford from Bristol as an expert, because everything involving planets and the solar system, we had to completely rewrite. And I think, you know, these things do go in phases, and I think maybe we're entering a phase with the planet story where the details will matter. We've got to sort that out. But cosmology, I hope, is ripe for another disruption, and maybe one of these, some of these JWST results, or the ongoing controversy about how old the universe is. There's a slight discrepancy between various methods. Nothing as dramatic as the crazy stories of stars or black holes much older than the universe, but there is this slight discrepancy called the Hubble tension that will not go away.
Gets worse.
Well, slightly worse, but yeah, but it's certainly, I think we're close to the point where we know no one's made a mistake, right? It's not that there's some silly error in a program somewhere, and actually if you resolve that, it's fine. There's something about the universe that we don't understand, or something about the things in it that we're using to measure its age that we don't understand. And so I think hopefully that will blow cosmology wide open, because that would be fun.
Yeah, so the Hubble tension, what's your feeling there in terms of are people going, is this going to take a little bit of luck? Is this going to take one of your, serendipitous...
Well, you'd like somebody to have a spectacular theoretical idea. I think the luck answer would be, my guess is that there's something we don't understand about supernovae. I would say the most likely outcome is that we're missing something about how supernovae work. And the thing that would resolve that would be a beautiful nearby supernova. So it would be wonderful if maybe sometime before the paperback edition of the book comes out, we could have a nice, bright, nearby supernova.
Like Beetlejuice? Well,
that's got 1 million years or so to last. And actually, when it faded in 2000, I think we talked about this before, I was very upset about it fading. So I want Orion to remain the same, but maybe something a little further away, but still in the galaxy. I did actually, one of the stories at the start of the book was from when I went to Gran Sasso, the great underground particle physics lab in Italy, basically in the mountains east of Rome. It's an amazing place. You get there essentially by driving into a James Bond lair. You pull off the motorway, say a password, and a giant door in the wall opens. It's great. But there's an experiment there run by a bunch of very serious German physicists, which is there to detect neutrinos, for these high-energy particles, from the next supernova in our galaxy. And it's been running for 15 years. We haven't had a supernova in our galaxy for it to detect. And they're desperate to shut it down and upgrade it. But even highly efficient German engineers believe that the moment they shut this down, the supernova will go off. And so they were genuinely talking about whether they could bear to, even though they didn't be shut down for 6 months, they felt this would trigger an inevitable supernova. So
surely
maybe
someone else has one. Surely the Chinese.
Well, not the sensitivity. You see, that's the problem. But So maybe this means that publishing the book will mean that all the stories will instantly be rendered out of date by new discoveries. So I might have done a favour for astrophysics in publishing this.
Well, let's hope so. So, I mean, there's one kind of part of this story I think we probably haven't touched on, and that's the kind of effect that astronomy has on culture and society. Do you talk about that much in the book and kind of how it leads those?
Less so. I think, as an astronomer, I'm more inside it than that. But it is fascinating to see how, imagery from JWST pops up all over the place. Or, my friend Katie Mack, who's had the experience of being at a rap concert and discovering that the extremely successful rapper has both read her book and has included her in several of the songs. Which is, there's a life goal there. If any of your listeners are highly successful rap artists, then by all means, please include the book. So I think it does bubble out in all sorts of ways. And we talked a bit about, I think, the appearance of astronomy in the news. I think one of the things that we serve a purpose for at the minute is that I think a story about the distant universe or about our solar system doesn't ask you to do anything. And I think in a world that's quite stressful, where politics is time-consuming and stressful, and where, but suitable focuses on things like climate change, which comes always with an undercurrent that we should be doing something, either collectively or individually. I think, reading a nice story about a lunar eclipse or about the colour of Neptune or about the discovery of a distant galaxy, you can sort of read it and go about your day. So I think that sense of being in a universe and just enjoying it is something that culturally goes down very well. I do also, I have a long-standing show that we're touring, I think, this year with my friend Steve Pretty, who's a jazz musician, in which he talks about jazz, tries to explain jazz to me, and I try and explain astronomy to him. And it's interesting how many connections there are to all sorts of arts and understandings of the world from what is essentially a hardcore science involving saying the word billions a lot.
Well, I mean, you've already mentioned it once, haven't you? Like Brian May. I mean, you've worked with one of the greatest rock guitarists and most celebrated musicians on the planet. But there's a lot of them, aren't there? And I've noticed that most of the people that I've met at ESA and are all sort of obsessed by some form of art and music, and there's a connection there.
Yeah, it's almost. I think there was a lovely quote about the book from Lucy Rogers, who said, this is something like this wonderful book about the cosmos from the most human astronomer. Which is a beautiful compliment, but also, we are also people. And the book makes it very clear that many of these people have their own obsessions and connections. It's not always real tennis, but yeah, I think that's right. But if there's any connection there, if there's any reason why there's more likely to be a connection to things like music, I think it's because, as I found out, finding words for the feeling of being in a universe that's much richer and grander than we could possibly have imagined, that has many more surprises in it. Sometimes, you need to sing about that, or to have, in my case, somebody else sing about that, rather than to write equations and prose. So I think there is this expression of where we are in the cosmos that needs more than a dry scientific paper. Sometimes it's helpful to collaborate and to reach out to others.
Maybe everyone underestimates what it would mean. For example, I did hear, I think it was Dr. Becky was sort of saying that she actually had a prediction that this might be the year that we actually get an unambiguous sign that there is an exoplanet that has a biosignature, which I still think sounds very ambitious. But if that's the case, I mean, it really does, that there are other planets with life on. If that was confirmed, that really subtly does change everyone's perception. Like that every human being living on Earth must have to change something about the way that they see themselves in the universe.
Yeah, so the first thing to say is I think a year is way too short for that. Certainly if you use the word unambiguous, because, which I don't think Becky did, but it's going to take us a long while to understand what we're seeing. We've got this biosignature on Venus, phosphine, and no one, including Jane Greaves, who led the discovery, will claim that's definitely a sign of life. It's a sign that we don't understand the chemistry, but now we need to do lots of work to try and understand that. And doing that at a distance is hard. But yeah, finding life in the universe, even simple life, would be obviously one of the greatest scientific discoveries of all time. I think up there with relativity and evolution and the idea that we're not alone in the cosmos, particularly because I think the search for life is so hard that succeeding even once would tell you that life was common in the cosmos. Yeah, the odds of us finding the only other life are incredibly low. So it tells you that the universe is filled with life, and therefore, presumably, even if we find simple life, it's not too much of a stretch to extrapolate to the hope, at least, that there'd be beings like us out there somewhere, which, as you say, does, I think, change everything. Just as I think knowing that planets are common in the galaxy has changed the way I look at the night sky, because I feel now I'm looking at a map of worlds that we might one day explore. I'm not likely to myself, but we as a species may go and see some of these places. But I do wonder I've been getting involved a bit in SETI, because if you're looking for unusual things in the universe, it turns out you're doing SETI, you're searching for aliens, whether you mean to or not, because they're a category of unusual things that you might find. And there's the shibboleth in the SETI community that discovering intelligent life in particular would be the most profound discovery ever made, that it would have all sorts of consequences for everyone. And I'm not sure that's true. I mean, I'm prepared to admit if the spacecraft hovers over 10 Downing Street, I think that would probably lead the news bulletins. And yes, I think if we got a signal sending prime numbers, that would lead the news bulletins. But it's interesting talking to people. I get the impression that most people assume that there's life out there anyway. And so it'd be nice, I think, for people to have that confirmed. But I think it's interesting. It's in most people's worldview because of science fiction, because of the way that we've talked about the search. I think actually for many people, the radical idea would be that we're on our own in the universe. I think that's the thing that would shift people.
That's a harder one to prove, isn't it? The null.
Yeah,
null
but you can imagine a world in which we invest heavily in finding unusual things and then don't. So if we could survey the nearest 200 Earth-like planets, for whatever definition of Earth-like you want to use, and don't find something, I think that will almost be the bigger surprise, I think, for most people, which is not to say we're going to stop looking for alien life, because it would be important scientifically, but I just by the number of people who ask me whether I've found aliens yet, I'm not convinced that people have quite taken on board how hard it is.
I think you're absolutely right. I've had that impression for a while now. When I talk to people, or when people talk to me, that it's almost like an article of faith, isn't it? It's like, do you believe that there's life out there in the universe? Well, I do.
Say there must be.
Yeah,
right?
There must be, and it's like, well, you can't just say that. But I think most people, that's how they operate, isn't it? They have sort of articles of faith and worldviews, and
I mean, most scientists do too, right?
Yeah.
So, and that
I was including scientists with most people. Yeah.
Well, we're just checking that we count as people.
Well, you're the most human of all of them. So.
That's right. Yes. Yes. All the rest, we have found alien life, and every astronomer but me is actually from the planet Zog. I'm happy to reveal that on this podcast, and only on this podcast. Or you can buy the book. But yes, no, I think that's right, and I think in some ways that's why it's hard to get support sometimes for SETI, because we're almost looking for a truth, right? That we're going to find life, and great, and then we can move on. But yeah, it's interesting to try, and I think in the SETI community, this idea of being surprised has really taken hold. I think that whereas 10 years ago, maybe the focus was on deeper radio surveys and better searches for signals, which we're doing lots of. There are people in this building who are working on new ways to search for signals in radio data, targeting SETI searches. I think there's a much broader understanding. Should we look for flashes of laser light in the sky? Should we look for ways that aliens are manipulating stars, maybe? Can we look for the side effects of aliens mining asteroids? Can we look for spacecraft in the solar system. Maybe there's something on the moon. Who knows? But there is this broader sense that if you're going to look for alien life, we can broaden the range of things that we look for.
Talking about just what life is as well. I mean, presumably that we only know one type of life, and it's quite hard to nail that down. But yeah,
that's true. Although once you let go of that, then it's very difficult to know what you're looking for. So once you say anything can be life, then anything can become a technosignature or a biosignature, and so then you're sort of left wondering at the universe, but maybe not being able to distinguish. So, I think it's a reasonable hypothesis to look for our kind of intelligence and our kind of life, and as I keep saying, prepare to be surprised if something doesn't fit that mold.
Whereabouts is the best place to get your book and
Well, you can get Our Accidental Universe from, as they say, all good bookshops, including several well-known online bookshops, which would be nice. The audiobook will be available in all the normal places as well. And if you want a taster of some of the stories that's in the book, this year's series of Gresham lectures are all on YouTube. So if you look for my name plus Gresham, you'll find it there.
Oh, that's what I'm immediately going to do after this. So
Good stuff.
Yeah, excellent. Thanks very much for coming on and again entertaining me.
Pleasure. Always happy to chat.
Thank you very much.
All right, take care.